Early caregiving plays a critical role in shaping the development of the hypothalamic pituitary adrenal (HPA) axis, which underpins stress regulation. Disruptions to early caregiving have been associated with long-term alterations in stress biology and elevated risk for psychopathology. While extensive evidence demonstrates that variations in caregiving behavior impact biological outcomes, translating these findings into effective interventions remains complex. This essay will explore how early caregiving experiences influence HPA axis development, the consequences of disrupted caregiving on child psychopathology, and how these findings inform intervention efforts, critically evaluating the limitations of current research along the way. Animal research provides key insights into how early caregiving shapes the stress response. Rodent handling studies, Levine, 1957, demonstrate that brief, daily maternal separations in early life can lead to an enhanced stress regulatory system later, characterized by smaller stress responses and faster recovery to baseline. Subsequent work by Liu et al., 1997, identified that these effects are mediated by increases in maternal behaviors, such as licking and grooming, LG, which in turn increase glucocorticoid receptor, GR, density in the hippocampus, enabling improved negative feedback control over the HPA axis. These findings have been instrumental in demonstrating that early life experience can program stress biology. However, while rodent models offer valuable mechanistic insights, they are limited in their generalizability to humans, where caregiving encompasses a broader range of emotional and social processes beyond tactile stimulation. Moreover, human infants experience longer developmental periods, meaning that timing and sensitivity to intervention may differ significantly. Human studies have replicated the importance of caregiving sensitivity in stress regulation. Blair et al., 2006, reported that infants with more sensitive mothers exhibited lower baseline cortisol and more adaptive cortisol responses to challenge tasks, indicating better stress regulation. The large sample size, n equals 1292, indicates good statistical power and strengthens the reliability of these findings. However, the measurement of maternal sensitivity during a single 15-minute observation raises concerns about ecological validity, as parenting behaviors may vary across different contexts and over time. Similarly, Halligan et al., 2004, found that adolescents exposed to maternal postnatal depression, PND, displayed elevated morning cortisol levels, independent of concurrent maternal depression. This suggests long-term programming effects arising from early caregiving disruptions. Yet, cortisol sampling only twice daily limits the ability to fully characterize diurnal cortisol patterns, potentially underestimating the extent of HPA dysregulation. Collectively, these studies support the notion that early caregiving environments critically shape HPA axis development, but methodological limitations highlight the need for more fine-grained longitudinal designs. Disrupted caregiving environments have profound consequences for child development and psychopathology. Research into Romanian orphanages provides a naturalistic example of extreme early deprivation. Carlson and Earls, 1997, found that children raised in institutions displayed flattened cortisol rhythms, muteness, and stereotypic behaviors, resembling socially deprived macaques. Subsequent adoption studies by Gunnar et al., 2001, showed that although previously institutionalized children exhibited a return to a typical cortisol diurnal rhythm after adoption, those adopted after 8 months still had elevated morning cortisol levels. These findings suggest a degree of plasticity in the stress system, but also indicate that longer exposure to deprivation may lead to more persistent biological effects. Nevertheless, it is important to acknowledge potential confounding factors in these studies, including malnutrition, prenatal exposures, and the socio-emotional quality of post-adoption environments, which may also contribute to later outcomes. In addition, maternal separation studies in rodents, Francis et al., 1999, show that separation longer than 3 hours per day results in increased HPA reactivity and reduced GR density in stress-regulating brain regions. However, the simplicity of the rodent environment again limits direct translation to human caregiving, where separations may occur within richer social contexts and are buffered by other caregivers. These findings have clear implications for the design of preventive interventions. Early interventions that focus on enhancing parental sensitivity and responsiveness appear particularly promising. For example, the Attachment and Biobehavioral Catch-up (ABC) program, highlighted by Gunnar et al. 2006, aims to increase parental nurturing behaviors and has been associated with improvements in child stress regulation. Similarly, therapeutic foster care programs have demonstrated improved behavioral and physiological stress outcomes in maltreated children. These interventions suggest that bolstering the caregiving environment can recalibrate disrupted stress systems, particularly when delivered early in life. However, significant challenges remain. Translating rodent findings to human interventions is complicated by differences in timing, complexity, and environmental variability. Moreover, some biological changes, such as those observed by Carlson and Earls, 1997, appear resistant to later intervention if critical periods are missed. Neurobiological markers like cortisol levels offer potential tools for assessing intervention effectiveness, but the heterogeneity in HPA axis responses among maltreated children complicates the use of a single biological outcome measure. In addition, as Gunnar et al. 2006 highlight, interventions must account for individual differences in resilience and vulnerability, which are not yet fully understood. In conclusion, early caregiving experiences play a fundamental role in programming the HPA axis, with profound implications for later emotional and behavioral health. Both animal and human research highlight the sensitivity of the developing stress system to variations in caregiving, although caution is needed when generalizing from animal models. Disruptions to early caregiving can lead to long-term dysregulation of stress biology, increasing the risk of psychopathology. While early intervention programs targeting parental sensitivity have shown encouraging outcomes, challenges remain in translating neurobiological insights into effective, widely applicable preventive strategies. Future research should prioritize longitudinal, ecologically valid studies that integrate psychosocial and biological measures by combining repeated cortisol sampling, neuroimaging of stress regulatory circuits, and longitudinal assessments of caregiving behavior across diverse contexts to better understand individual differences and optimize intervention timing. By doing so, it may be possible to more effectively prevent the emergence of mental health problems rooted in early caregiving disruptions.